Hey everyone, today I'm going to talk about the Hinge Joint 2D in Unity. The Hinge Joint 2D is a very versatile, physics-based 2D joint. It can be used to make objects rotate around a point in space. For example, you could make a basic pendulum or even a physics rope. Let's take a look at the documentation for the Hinge Joint 2D so we can get a glimpse into how it is supposed to work and what properties it has. Okay, now we're in the Unity documentation. As you can see, the hinge joint is a 2D component that allows a game object controlled by rigid body physics to be attached to a point in space and rotated around it. The rotation can happen either actively or passively through using motor components, and you can also limit the rotation of the game object using the angle limit properties. As you can see, the hinge joint 2D has many properties. The ones that are most important, however, are the anchor and connected anchor properties. They define the distance from the anchor and the positions of the anchor or displacement of the anchor respectively. Now that we have an idea of what the Hinge Joint 2D does and what its important properties are, let's move on to a Unity test project so we can see the hinge joint in action. Okay, so I already have a test scene built, so I can show you a basic implementation of the hinge joint. This basic pendulum, and also a rope. So these are two things that we could make. But let's start from scratch and build our own. So I'm going to create a new scene. And let's add a game object and get started. Let's scale this box up on the X so that we can see some interesting things about its rotation. And scale it down on the Y so that it's more like a plank. Now we're going to add a box collider, rigid body 2D, and a hinge joint 2D. As far as I know, you only need the rigid body and the hinge joint for this to work, but the box collider will allow us to have collision, so we're going to add it too. Okay, now that we have our game object built, let's investigate how the hinge joint works. So if we look to the right on the inspector, we can see that auto configure connected anchor is enabled by default. So what this means is that when I drag around the game object, this is going to change, and as you can see here, it sets the connected anchor to be the position of the object. We're going to disable this for now, but we'll come back to it later. So I'm going to turn off auto configure connected anchor, and we're going to go back to looking at the scene view. So in the scene view, you see this green circle. This circle represents the anchor point for the hinge joint, and we can see that our anchor point is currently 0, 0. So the anchor is basically the offset from the connected anchor position. So we see that whenever I drag the game object, it just snaps back to where it was before, which is an offset of 0 from its connected anchor. So what I'm going to do now is change the anchor to 5 on the Y. This means that the game object is now going to have an offset of 5 units vertically from the connected anchor. So now we can see that the game object is below the connected anchor point, and it rotates around that point with an offset of 5 units, and it maintains that distance. So wherever it is in its rotation, it's always exactly 5 units away from its connected anchor. So we've seen what happens when I set the anchor point to be outside of the object. Now let's see what happens when I set it to inside the object. So I'm going to set it to the top left corner of the game object, and we'll see how the rotation changes when I do that. So now that we've set the anchor to the top left corner of the object, let's see what happens when we hit play. So as you can see, the game object rotates from that top left corner. Also note how the game object snapped to a different position when I hit play. That's because the connected anchor was not where it was, so it snaps to where the connected anchor was because that's the point that it's going to rotate around. Okay, now let's investigate how the motor component works inside of the hinge joint. So I'm going to check the use motor boolean, and I'm going to give it a motor speed of 90, and we can see that it rotates clockwise when I have to give it a positive value. Also, the speed that you give it is in degrees per second, so it's going to rotate 90 degrees per second, but if I up it to 360, it will rotate one full circle every second. But let's lower it back down to 90. Okay, I'm going to go ahead and turn this motor off, and we're going to look at the angle limits now. So I'm going to set this to 0 and turn use motor off. So now we can see that this is just hanging. So I stopped the play of the game, and now we're going to turn on use limits in the inspector. So we can see that nothing changed visually, but now when I change these values, that green circle gets smaller, and that shows us where it can rotate. So the object is going to only be able to rotate inside the bounds of the shaded green area. So it won't be able to rotate here. The object will never be able to swing on this side. It will have to stay within this 90-degree arc. We can see that if I turn off use limits, the circle is automatically full, and changing the lower angle or upper angle doesn't affect it at all. But for now, we're going to turn it back on and see that when I hit play, the game object stays in this radius, or stays within this arc. I'm going to turn the motor on again, turn it on to -50 so that it rotates this way, because by default it rotates clockwise, so making it negative makes it rotate counterclockwise, and we can see that it stays at the max. Stays within the arc. If I increase this arc to 180, now we have a greater range of motion. If I made it 360, then we could rotate in a full circle, but no more than a full circle, which is important to note. So I'm going to make this 400. And we can see that this will be able to rotate. If I turn on the motor, turn it on to say 60, it's going to rotate all the way through the overlapping area, so it makes a full circle and then stops right there. So that's how the angle limits work. Let's turn off use limits and reset the anchor back to its default position, 0, 0. Okay, now let's reset our game object and look at connected rigid body and connected anchor. So right now we can see that the connected anchor, -4.38, -0.45, is actually the world space coordinates of the point where it's going to rotate. So if I set this to 0, 0, it's going to move to the center, and now it's rotating around the center of the screen. So what this means is wherever I move it, this is where the object is going to rotate around. It's going to rotate around whatever point you set for the connected anchor. Okay, now let's see what the connected rigid body property does. This is a pretty important one because it changes how the anchor and connected anchor variables behave. So for that, we're going to have to create another game object. This time we'll make a static physics box. Just drag it up here. It already has a rigid body, so that's fine. And let's make this the connected rigid body in our hinge joint. Also, let's set connected anchor back to 0 and leave auto-configure connected anchor unchecked. So now we see that because the anchor is 0, it's snapped back to this position. So we're going to go ahead and make this 5 again so that we can have that normal hinge joint offset. So here's what you're going to notice. When I move this box, because it's the connected rigid body, the game object that we're rotating with the hinge joint, this plank, moves relative to it. Another thing you'll notice with having a connected rigid body is that the connected anchor is no longer world space coordinates. This box is at -4, 3. Let's actually put it there. Exactly. It's at -4, 3. And the connected anchor is not at -4, 3. So when there's a connected rigid body, connected anchor is no longer world space coordinates. It's actually local space coordinates for the box. So it's a 0, 0 offset away from the box's position. So if I made this 1, now it's 1 unit on the x, 1 positive x value unit away from the connected rigid body's position. So I can make it 1, 1, it's going to be up to the right. I could make it -3, 0, so now it's 3 units below where the box is. When I move the box, it still moves relative. Alright, now that we're here, this is a good place to show you the enable collision value. So right now, I'm going to go ahead and turn on the motor to 90. We're going to see that our plank does not collide with this box, with the connected rigid body. But if you turn on enable collision, it will collide with the connected rigid body. That's all enable collision does. It's pretty simple. Okay, the last things we have to look at are brake force and brake torque. So basically, brake force is the amount of force that has to be applied to the object to make the hinge joint break. So what that will look like is, I'm going to go ahead and scale this up so I can show you. And create another 2D object, a physics object, a dynamic sprite, and we're going to try to add a lot of force to this hinge joint by dropping something very heavy on it. So I'm going to make this mass 200, and I'm going to set brake force to 4. So when I hit play, set brake force to 40. Set anchor to 5. Okay. When I hit play, the force from this heavy object falling on the game object makes the hinge break. Okay, now that we've looked at most of the properties of the hinge joint, we're going to look at maximum motor force. So what maximum motor force is, it's the maximum force that will be applied in the background to make the object reach the motor speed that you set. So if I give it a motor speed and set a low maximum motor force, it will never reach that goal speed because the motor force isn't high enough to actually make the object reach that goal speed. If I set maximum motor force to 10, let's say I want to achieve a speed of 360, we'll see that because it's only allowed to add 10 force, we'll never achieve that speed of 360. Okay, now we've looked at basically every property of the Hinge Joint 2D. I hope you have a better understanding of how to use it and that you can use it in your future projects. Thank you for watching.